Okay, everyone. We're going to be looking at angle relationships. And the big jump between all the earlier grades versus grade 7 and 8 is you're sort of no longer using a protractor. You're using what you know about the different relationships between certain angles and being able to solve them mathematically, algebraically, whatever it happens to be. Yeah. So I'm going to have a hard time because my stylus just died on me here, so I'm doing this with my finger, believe it or not. So angle relationships. So the first thing that you want to look at is just a bit of review. How do we name angles, right? So if I have this angle here, what I could do is I can label it like this, okay? And I'm going to be naming that angle based on this vertex. Okay, so the cool thing about this is I have 3 different ways I can label this specific angle. So I can call it angle, whoops, I'm going to go back to a pen, angle A, B, C. I can also name it angle C, B, A. And lastly, I can also just label it based on the vertex, angle A. But the important thing is you're going to notice that the B is in the middle here. That has to be in the middle. So you can't call it angle BAC, for example. So that letter has to be the vertex. I mean, there's no other way around it. So that center letter is the vertex of the angle. Now the vertex is that corner, right? So it's where those 2 lines or line segments meet. The other way that you could look at it is if you had just this, and notice how above in this first angle everything's in capitals. We could do this, and then we can call that angle M, and that's in a lowercase. Okay, so what we want to look at is now looking at how all these angles relate to each other. You did a little bit of classification last class, and we did it based on triangles, but you should know by now that this is called an acute angle, and it's anything from 1 degree all the way up to 89 degrees. Okay, and then we have this guy. Doesn't look so accurate, but I put that box, and now we know that that's a right angle triangle, or a right angle, I'm sorry, and that equals exactly 90 degrees. And then if we go a little bit past, and I want to do that one, I know it's an obtuse angle, and that's going to go from 91 degrees all the way to 179 degrees. And then there's this guy. That was pretty good. Pretty good, Greenhill. If I want to measure that, that's a straight angle or a straight line, but if we're dealing with the angle, we're talking about a straight angle, and that's exactly 180 degrees. And then if I want to go, that looks like an acute angle, but I actually want to go this way and measure whatever's left over. That's called a reflex angle, okay? And that's anywhere between 181 and, 359 degrees. And then if we want to go to 360, you should know, that's not too bad. You should know that that whole thing, that full circle, is 360 degrees. Okay, so we're going to move right along, and we're going to go to the next guy. Okay, So what we have here is we're looking at the relationship between two angles. And the first relationship that I'm going to sort of go over with you are complementary angles. Complementary. Nice long words. Angles. Okay. So the deal about complementary angles is that if you notice this angle and that angle, those two angles are complementary to each other. They have a sum of 90 degrees. So the sum just means that they add up to 90 degrees. So if I want to check that, I can do 27 plus 63 equals 90 degrees. Okay, in terms of this, what's going on with this diagram. Okay, they can be free floating like that, in terms of if I give you a whole bunch of angles on a page and I say find pairs that are complementary to each other, you could do it that way. But in terms of this lower diagram, these are going to be typically what you would see. This is a question that you would have seen last year. You did complementary, supplementary, and opposite angles last year, and this is just a bit of review of that, but I am going to give you more complex diagrams, so buckle up, guys. So here is a diagram, and you know that based on that complementary relationship that they add up to 90 degrees. So we want to be able to solve for x. Okay, so we've got to find x, right? And so what we're going to do is we're going to say, well, I know x, we're going to solve this algebraically too to get you in the practice, right? X plus 62, because I know those two angles together, these two guys, are going to equal 90 degrees. Okay, and then we isolate our variable, so we're going to do x equals 90 minus 62, right? Because we know that we've got to take away 62 from this side, so I'm also going to take away 62 to balance it on that side. So x, therefore, so we're going to do 90 minus 62 is 28 degrees, okay? And then this has a complementary relationship, so your proof is comp, okay? So again, we're not using protractors, you're using relationships, but these are called angle proofs. So it is really, really important that you get into doing these. By the time I'm finished with you, you'll have learned, I think, close to 10, either 10 or 11, or yeah, something like that. So we're just starting with review, because again, this should have been covered last year, but you know, it's been a while. So we're going to move on. So just remember, show it algebraically. So we've got this shown algebraically, right, our statement. So that's a key thing. And then you're going to solve it algebraically. You need to make sure that you include your degree symbol, because that is your unit of measure, and then you want to include the proof for it. Okay, so the next guy. So these two angles, again, you'll notice with this group, they're free floating, right? These are called supplementary angles. Okay, and hopefully you're kind of saying this out loud, like, this is boring, we've already done this, blah, blah, because again, this is a bit of review, because I'm about to, I hope I can give you some complex angles to do. So the thing that we know about supplementary angles is that they add up to 180 degrees. So sum of 180 degrees. Okay. So if I take it from this diagram, it would say 60 plus 120 equals 180. okay? So then we want to figure out how to use what we know in order to solve for this missing angle. Again, find x, there it is, haha. Find that missing angle within the diagram. So I know that my x value plus the 118 degree angle is equal to 180, because I already learned that up here. So again, I know that in order to balance off this equation, I've got to subtract 118 from this side, which means I have to do the same thing over here. Okay, those are for the balancers. I know a lot of you prefer to do inverse operations, and I don't really have the quote-unquote board space to do everything, but those are your two balance amounts. So we're going to say x equals, if we're doing inverse, we're going to go 180 minus 118, and then therefore x is going to equal 62 degrees. And I know this because they have a supplementary relationship. So it's sup is your short form. Okay, so again, we want to set this up algebraically. Okay, we want to do the math. We want to make sure that we include our unit of measure, and then we also want to make sure that we include the proof. Okay, so hopefully, so far so good. Now we're going to get, oh, sorry, I forgot about this one. I have noticed in the past that sometimes students get supplementary and complementary mixed up. The thing that I typically do is I think in terms of 90 is a smaller number than 180. It comes when you're counting, 90 comes before 180. And then if you think about it, C comes before S alphabetically, and 90 comes before 180 when you're counting. So the lower number matches the letter that comes before, or yeah, I guess before versus after. But the reason why I was surprised that I included this screen is that this is a new thing that I've found. Like every year I find new stuff. It's kind of cool. So you'll notice that in the 9, they've written a C, and then in the 8, they've written an S. So I don't know if that is going to help you. Either way, like some of you are just going to memorize and you'll know that 90 is complementary and 180 is supplementary. But I always try to find ways to help you remember them. So whichever thing helps you remember it, then use that. So we're going to get to the next one. These are, excuse me, get the right pen color, right? That's the most important thing. They're called opposite angles. You will also see it as vertically opposite angles. And don't think in terms of vertically as like you know that vertical goes up, down. Okay, it's not that in this case. Okay, so we're not dealing with that. What we are dealing with is the fact that this is our little root word, and it's vertices. Okay, so vertices is the plural of vertex. So they're saying that this vertex is opposite to that vertex. Okay, so, or just remember opposite. I also always say, like, find the X, and then, you know, the two things, that looks like an angry face, but the two things that sort of meet as if you've got like two fish that are kissing or something like that. So based on this diagram that is here, it's weird. I can't just point to stuff because you can't see that. A and B are equal, and then I could say that this is angle X and this is angle Y, for instance. So I could say that angle A equals, angle B, and I could also say that angle X equals angle Y, okay, which is kind of cool. And that looks like it says CY, but it's angle Y. Okay, so going down to this example, I'm going to show you how to solve this algebraically. The very first thing that you want to do is you want to mention things, like you can't just say what it is, because remember, we're dealing with proofs. Okay, so we can look at this and we can say, well, I know that these two vertices are opposite to each other, okay, because they look like two fish kissing, whatever. So I'm going to say that angle B equals 40 degrees. Okay, I'm going to show you two ways to solve this actually. And I know that because of the opposite relationship. So OPP op is going to be your proof. Okay. Then what I want to do is isolate either A or C. And I can look at it the first way I'm going to look at it is I know that angle A, okay, actually I'm just going to, I know that A plus 40 equals 180. So what I'm now doing is I'm going to highlight this for you. Normally if we were in class, I'd be showing you how you can cover over these diagrams. So all I am looking at right now is this section of the diagram. So I would almost completely cover over, like I'd take a sheet of paper and cover over the C and the B, because I don't need it right now. And some of you that are a little bit more spatially challenged, we like to say, to be politically correct, if you cover over the parts of the diagram that you may not need, it helps really clarify what you're doing. So we're just isolating A and 40, and now you can see that they're supplementary. So there's a straight line running through. 40 and A are beside each other. They're actually adjacent angles. They're not opposite. So we're going to isolate and we're going to solve for A. Okay, so I've already set it up algebraically, so now I've got to isolate my variable. So it's going to be 180 minus 40. For those of you who are balancing, remember I'm subtracting 40 from this side to make it 0, so I have to subtract 40 from that side to make it 0. And then I'm going to say that angle A equals 140. I was about to put just 40. 140 degrees, okay? And then I know that because it has this 180 degree relationship, right? Two angles equal 180 degrees. Because I know that, it's going to be supplementary. Okay, so here's where it gets more tricky because we're dealing with multiple proofs. We've already got op going on because that says that this is 40 degrees. And now I solved for angle A, so I know that that's 140 degrees, okay? And then I can just say angle C equals angle A, because I know angle A now, which equals 140 degrees as well. And I know it because of the opposite relationship. Because if I want to say that those two angles are equal, I can't say that they're supplementary. If I say that they're equal, they have to be opposite. So now I can fill in that 140. Okay. The other way to look at it is to take that full, 360 degree measure. So I'm just going to quickly, I think that's the eraser. Nope. I seem to have lost my eraser. Okay, I don't want to waste your time, but it seems like my eraser is not there it is. Yay, I have an eraser. Okay, sorry to waste your time, guys. So the other way that I can look at it is I can look at it from a circular point of view. So I know that this whole area here, this whole thing is a circle, okay? So the other way that you could look at it is saying that we have $180. Why am I saying 180? I'm not saying 180, sorry, blah. Say we want to isolate for A plus 40. We've already established that B is 40, right? So A plus 40 plus 40, or you could say A plus 2 times 40. 40. So A, and then how many A's do we have? We have one value of A here. I know that this is equal to that, right? So I know that if this first value is A, then I'm going to call this A as well, even though it's labeled as C on the diagram, but it could be 2A plus the 40 that I was given. This one here is called a given. I'm making a mess out of this diagram, I'm sorry. That's a given. And then the 40, that is the opposite relationship, I now know. So I can say I have 2A plus the 40 degree given plus the 40 degree opposite is a total of 360. Okay, and then I just solve that algebraically. So I know that it's, this is 80 altogether, so I'm gonna say 2A equals 360 minus 80. And then 2A, I'm running out of room here. Okay, so 2A equals 360 minus 80. And that's going to be 280. Okay, and then we're going to divide both sides by 2. And I'm just going to come up over here. And I know that that and that cancel each other out. Whoops, or cancel out. So 2 divided by 2 is 1. So I've just got A left over. And then 280 divided by 2 is 140 degrees. And then my proof can actually be that it's a circle. Okay, and that didn't work when I wrote it. Circle. Okay, so sorry this is a little bit messy, but I hope you followed along. And now we're into the next thing. Okay. Here's where your grade 7 sort of singular diagrams get more complex, and you're going to get a few more complex ones as we go. We're almost done though, okay? So bear with me, folks. What you want to do is you want to look at this, and we know that we have to solve for angle P, and angle N. So again, what you want to do is start to kind of look at your diagram, cover things over if you need to. Remember that you're only ever allowed to have one unknown, unless, just like the last page that we were doing, 2 of those angles were congruent or equal. So then we can solve for more than one of those variables. But right now, you can tell by looking at these that M and N and P likely are different. And I'm going to caution you, do not assume that M and N are the same, because they kind of sort of look like they might be. Because remember, you might be at the mercy of a Greenhill diagram that I've hand drawn, and you can't eyeball this stuff. Okay, and you have to be able to prove it. It's not enough to say, oh, well, it looks like that, right? You got to have the mathematical proof. So I'm going to be looking at this as a straight line. If you see it in another way, that's fine, but you've got to, I think, there are a couple other ways you could look at it, but we're going to go from there. So I know that if I if I do m plus 56 plus 63, I'm going to get a total of 180. Okay, so right off the top, I know that because it's 180, this is telling me that I've got a supplementary relationship happening with those angles. So first thing I'm going to do is I'm just going to simplify this and add it, or you can kind of simplify it, add it, and then bring it over. Either way, I'll do it kind of the long way just so you see the process. So this is supposed to be a plus sign, I'm sorry. M plus 119 equals 180, okay? And then I know that M is going to equal 180 minus 119, because I brought it over. Again, balancing people, right? We've got to subtract 119 from that side, so I have to subtract 119 from that side. And then M is going to equal 61 degrees. And then again, I know that this is a 180 relationship, so my proof is sup. So again, you want to include that diagram, that degree measure thing, sorry, and then the fact that it's supplementary. You have to include your proof. So what I typically do is I go through and I label my diagram as I go. It just helps, especially when these get more complex. This isn't too bad, but if it gets more complex, you're going to find that you're sort of all over the place. So it's good to kind of use that almost as a checklist to make sure you've covered everything over. Okay. The next thing that I want to look at, I'm going to highlight on top of highlighters, so hopefully that's not going to throw you off. I know that 56 degrees and angle N, they're touching at their vertex. So they make that X pattern, okay? Again, if I did that and then I looked at this is adjacent to 56, yeah. It's adjacent to 56, it's not opposite. So N and 56 are opposite to each other. So all I have to do is say that angle N equals 56 degrees because of the opposite angle theorem, whatever you want to use, okay? So now I know that that's 56 degrees. So my only last one standing that I have is, I think that says P, that one. So I could do it this way as a straight line. I could do it the other way, right? Coming across here, because that's 56 as well on a straight line. But we'll stay consistent. And you'll notice now that even though angle M and angle N kind of sort of look like they're the same, they're not, because one's 61 and the other one's 56. So now we're going to move on to angle P. Let's get the right color. So angle P plus 56 equals 180. Okay, and then angle P equals 180 minus 56. For those of you that are balancers, we're taking 56 away from both sides. Okay, and so therefore angle P, and this is going to give us, I forgot to highlight that before, we know that we're dealing with a 180 degree relationship. So, and that's the only one that, there's two actually, but this is the only straight line relationship that gives you 180 degrees. So it's pretty easy to keep track of, I would say. P is going to equal 124 degrees, and I know this because of sup. Okay, that's it. Now, I'm going to stop you here. we are going to summarize. So if I have two angles and I have a right angle and there's an angle there and an angle there, okay, and they're within this construct of 90 degrees, this is, okay, 90 degrees total, so sum of 90 degrees, and that is called comp is your proof, okay? If we have two angles within a straight line, whoops, not doing so well with my finger, and they have a sum of 180 degrees, I know my proof is going to be supp for supplementary. And then the last one that we did is we looked at two lines that are meeting or intersecting, in this case intersecting, where those vertices point to each other. That gives you an opposite relationship, and we can say that they're equal, right? Okay, so you're done if that's all you want. You have homework in your classwork that you can go over using the same type of strategy as I did. Please make sure that you show your work, and it's really important to have those proofs laid out. Again, by the time I'm done with you guys, you're going to have at least 10, and you do get more in higher levels in math. So once you get into high school, you're going to have more proofs. And we haven't even started yet. Okay, we're going to go to triangles next class. So go to classwork if you think you're done. If you want a challenge, I want to take you to the next slide and just show you something crazy. Okay, so I'm going to make this a little bit bigger. Here's how we integrate a couple strands together into a lovely little nightmare. Okay, so what you're doing is you're looking at what do I know about angle proofs, and then how can I integrate this into solving for a variable. So, whoops, I am going to move this guy into the corner because we might need a little bit of space. So the first thing that I want to show you, because I am going to give you the option of doing some of these. I have a few of these up my sleeve. So we're going to start with the idea of solving for A. So that's my variable I'm solving for. So you literally do this. So 7a plus 82 equals, because I know that opposite angles are equal, or vertically opposite angles are equal, it's going to equal negative 5a plus 76. Okay. Presto changeo, I'm going to do negative 7a plus 5a, because what I have done is I've magically moved this guy over, okay? And we do know it's a negative on the right side, so I'm going to have to balance that out by turning it into a positive on the other side. And then I'm going to do this at the same time. So I think what I'm going to do is kind of color code some highlights here. So I went from negative 5a on the first line to positive 5a because we're across the equal signs. And we want to look at 76 is over on the right side. And we are going to be moving 82, okay? So, and it's positive 82 over there, so it becomes a negative 82 over here. And I'm going to highlight it green. Apparently I'm a highlight queen for this one. And then we just simplify, right? So I have 7 negatives and 5 positives. So that means that I owe you $7 and I show up with $5, so I pay you back, but I still owe you $2, right? So the fact that I owe you, it's a negative. And then I look at 76 minus 82. I could either just subtract that and say I know 76 minus 76 is 0, and then how much further do I have to get to get to 82. Or you can also look at this as a debt repayment thing. So I have $76, but I owe you $82. And then, you know, can I pay you back? Do I have money left over? Do I still owe you? Well, in this case, I still owe you $6. Okay. So that's, remember, just simplifying integers. And now we've got negative 2a equals negative 6. So we're going to divide both sides by negative 2. Remember, it stays as negative 2. We're not changing it to a positive because this operation, which I'm going to highlight for you, this operation right here says I'm multiplying by negative 2. So times, right? So in order to offset it, I have to divide. Okay, so I'm not changing from plus, like, subtract to add. I'm changing from multiply to divide. So I don't want to change the integer at all. Okay, so if I have to multiply by negative 2, the opposite is divide by negative 2, so I have to do that to both sides. Okay, negative 2 divided by negative 2 is 1, so it leaves me with a, and negative 6 divided by negative 2 is positive 3. Okay, and you should be able to substitute those values back in. So you're not actually in this case solving for the angle measure. What you are solving for is what is the value of the variable. Then what you want to do is you want to come in and you want to substitute a equals 3 in for your original, I'm over here by the way, so your original expression, plus 82. So negative 7 times 3 is negative 21. We're going to add 82. Remember, I've got $82 in my pocket, but I forgot I owed you 21. Or we can maneuver this around, right? So as long as the sign stays with the number after it, I can move that around and say that that's positive 82, or just 82 on its own, minus 21, and it's still going to give me the same answer. So 82 minus 21 gives me 61. Yeah, 61 degrees. So this guy over here is 61 degrees. I'll actually do it in red so we can see it. So that's 61 degrees. And then if I want to come in and solve that guy, so see how much more involved these are. But you're actually doing some really good application because you are synthesizing. Oh, you're synthesizing so much. You're synthesizing what you know about solving algebraic equations. You're synthesizing what you know about integers. You are synthesizing your understanding of the angles. There's so much stuff happening. So we have negative 15 plus 76. Okay, and then remember, we're in standard form. So I keep telling you, these are like Scrabble tiles, right? So if I want to move this guy, I just have to take the sign with him. That guy, I have to take the sign with him. And I'm going to just move that and move that. So positive 76 is 76, because remember, you don't say I'm positive 14, you just say I'm 14. And then the negative 15 I'm going to put over here. And suddenly it becomes easy. Instead of, integers, negative 15 plus 76, and everyone panics. Now we've just got 76 take away 15. So 70 minus 10 is 60, 6 minus 5 is 1, so I have 61 degrees. Okay, so here's the deal. I'm going to ask you the question. Did I have to do this? Did I need to do this? That's the question. I hope you know that the answer is no, Miss Greenhill, you don't have to do this. The fact that I went through that is just to show you how to simplify and do all that stuff. But remember, if you know that 61 degrees is the measure of one of these angles, and you know that they are opposite to each other, then it further carries that this one is also 61 degrees. Okay, so you don't have to solve for both of them, but I was just showing you the substitution. Okay, so if you're interested, I have a couple questions like that. The only ones I've been able to find so far, based on opposite, complementary, and supplementary, are in this structure. But once we get into more complex diagrams, then I can provide you with more of these algebra type problems. Okay, so that's it. That's all she wrote. Good luck.